right, welcome back everybody. Today we're going to be graphing some more polar curves. Up until this point, you've already graphed circles and lines, the spiral of Archimedes, and most recently, you graphed roses. Roses are my favorite for the full symmetry. Limacons are very similar to that. They have beautiful symmetry, and there are four different types that we're going to look at. What we are, well, limacons are polar equations of the form r is equal to a plus b cosine theta, plus or minus, or r is equal to a plus or minus b sine theta. Now, depending on what's going on here, there's a couple things that affect the shape of the curve. A and b determine the shape of the curve, as do the fact that you're dealing with cosine or sine, because we're going to look at the fact of what is it symmetrical to in terms of cosine and sine. So let's start off with an easy type. The first one we're going to start off is something called a cardioid. Now, if you've ever heard the word cardioid before, to me that makes me think of the word heart. Let's take a look. So cardioid is where a divided by b is equal to 1. Now, in all reality, this should say is where the absolute value of a divided by b is equal to 1. Okay. How does that happen? Here's an example. R is equal to 3 plus 3 cosine theta. A is 3, B is 3, you get the point. What's going to happen is your curve will look a little something like this. Now, you're saying, what, Mr. Egan, what is that? Well, that looks a little bit like a cardioid, a little bit like a heart going this way. Not so much because it's not as pointy down here. But everything that's on here is described as the distance from the pole. Now, the maximum distance from the pole is 6, because the largest thing that the cosine can be is 1, 1 times 3 is 3, 3 plus 3 is 6. So right here is the farthest away from the pole I can be. And what you'll notice is that you can go all the way around the circle, and you could plot as many points as you want. You could plot the value of, let's see, pi over 3. The cosine of pi over 3 is a half. 3 plus 1.5 is 4.5. You could plot the value of pi over 2. The cosine of pi over 2 is 0. 3 plus 0 is 3. You can plot 2 pi over 3, which is negative 1/2 for cosine. 3 minus 3 halves is 1.5. You can plot pi. Cosine of pi is negative 1. 3 minus 3 is 0. So if you think about it, we just got all these points for the positive values of theta between 0 and pi. We can actually continue going all the way around, and we will see the same aspect. Let me go ahead and erase some of those. Now let's keep going. I won't go through all of these as time goes. But now what do we've got? This is called an inner loop limason. Now, in an inner loop limason, this is where the absolute value of a divided by b is less than 1. Absolute value of a divided by b is less than 1. Similar to this, r is equal to 2 plus 3 cosine theta. So in that case, 2 divided by 3 is less than 1. There's many values of a and b that could fit in there. And for this, it's going to look a little something like that. Now that is an inner loop limason. Why? Well, when we go around our circle, when theta is 0, cosine of 0 is 1, 3 plus 2 is 5. That's the farthest away you'll be. When theta is pi over 2, 0 plus 2 is 2. You're here, right? When theta is pi, 2 plus 3 times negative 1 is negative 1. So the value, this point right here, is the point pi comma negative 1, or negative 1 comma pi, r theta. So as we go around, when are you going to get 0? Well, you're going to get 0 wherever 3 cosine of theta is equal to negative 2, which is possible. Okay? So as we go around, we have a little bit of fun. We do our thing. Now, dimpled limasons, what are we talking about here? This is going to take that inner loop. It's going to create a dimple. This is anywhere where the absolute value of a over b is anywhere between 1 and 2. For example, you might see the curve r is equal to 4 plus 3 cosine theta. 4 divided by 3 is bigger than 1, but less than 2. It's going to take that inner loop, or it's going to take that cardioid, if you think about that, and it's going to push it away because this will never, ever, ever equal 0. If you think about it, if you graph this curve, the midline would be 4, you're 3 above and 3 below. This will never equal 0. R will never equal 0. R will be anywhere between 1 and 7. R will be anywhere between 1 and 7. Now, the values occur from plugging in theta. Again, we'll talk more as we go from there. Now, last but not least, there's something called a convex limacon. Convex is something that takes that dimple and pushes it a little bit further out. So we're over here, we got a divided by b is larger than 2. So for example, 7 plus 3 cosine theta. This one's going to look a little something crazy. What this did was it took that cardioid, or it took that dimple that was here, and pushed it a little bit further away, almost where it's flattening out. Now, this is not a circle. We learned what circles look like. This is a little bit flattened out, called the convex limacon. Now, what I'm going to do now is I'm going to go take you to Desmos. And when I take you to Desmos, I have to switch over the tabs here. And when I take you to Desmos, I'm going to go through all of the examples that we had again, and we're going to make it a little bit more clearer. All right. And tomorrow, or excuse me, not tomorrow, but in our next video, we are actually going to plot these by hand. So this is just an introduction. In our next video, I'll show you how to plot them by hand, and then in our calculator at the same time when I do that. Now, what do we have here? We have two types of curves, a plus b cosine theta and a plus b sine theta. Now start with cosine because that's what I just explained to you in the introduction. But we're going to start with what we had as a cardioid. Now this cardioid is 2 plus 2 cosine theta. Notice what happens. If I had the curve 2 plus 2 cosine theta, you can figure out what r is based on theta. When theta is 0, r is 4. Right? And we went all the way around the circle and we did our fun stuff. This would be true if I did the same thing. If I said, all right, what if I made it where a was 3 and b was 3? We'll make this a little bit bigger. Notice the largest thing you can get out is 6. Smallest thing you can get out is 3. Okay. I can go on forever. As long as these are the same, make this a 4, make this a 4, you have something known as a cardioid. Now, what changes with my cardioid when I make it a sine curve? Notice now you have the exact same graph, but you have symmetry with respect to the old y-axis. You actually say you have symmetry with respect to the line theta equals pi over 2. We'll cover that in our next video as well. Now, what happens if b was negative 4? Let's go back to the cosine one. What if b was negative 4? What that did was it took your curve and reflected it. Why? Because you now have a negative cosine curve. So when theta is 0, again, you have 4 plus negative 4 cosine of theta. When theta is 0, you get 4 minus 4. When theta is pi over 6, now let's do pi over 3. When theta is pi over 3, you have 4 minus a half. Or 4 minus 2, excuse me, which is 2. And you can go on forever. When theta is pi now, you have 4 plus 4, which is 8. Now, what's going to happen if I did that with sine? Well, got to do it here. I did it with sine. It's the same curve, just now pointing down in the negative y-axis, negative y's position. Now let's do some curves where we said, all right, so we had a cardioid where a is equal to b. Absolute value of a is equal to b, right? When we said, all right, if a divided by b was less than 1, so let's make a 3 and b 4. I want you to notice a couple of these points here. Again, a is 3, b is 4. 1, 2, 3, 4, 5, 6, 7. This is 7 units away. This is 3 units high, 3 units low, and 1 unit in this direction. You can figure out by plugging in values how they occur, and we'll talk as time comes tomorrow. The same idea, same exact curve. If I went ahead and drew it this way, 7, 3, 3, 1 come from the values 4 and 3. Now, what if I made it where, again, what we're trying to do is a over b is less than 1. If you forgot, I could also do here is I could do a over b to show you that it's less than 1. I can make this 2 and then make this a 5. That's a bigger loop in the middle because 5 minus 2 is 3. If I made this a minus 5, points down. Minus 5 for cosine, points left. Okay. Now, what others? I will post this exact thing right here on my MCPS classroom so you can play around with some of these numbers. I just want to go pretty quickly where a over b is between 1 and 2. So let's make this a 3 and let's make this a 2. There's your dimple. 3 plus 2 is 5. 2 minus 3 is negative 1. Where a over b is greater than 2. So let's make this a 5. Heck, you can make this an 8. And you can go ahead and do it in terms of sine if you want to. That's the hardest one to see. Let's make this a 3. Let's turn this one off. I will leave all of this on the MySPS classroom for you to take a look. So what I want you to do is go ahead and take a look at the next video that we're about to do. I'll do all of these by hand, and hopefully this was a quick little introduction. Have a good day.